For this last part of the section on decision trees, I will be walking through an implementation of a decision tree and a random forest. To do that, I will be using the well-known iris flower dataset. The link to the data for the iris flower dataset can be found on the SMLC website. Feel free to use any editor of your choice. For the purpose of this video and implementation, I will be using a Google Colab notebook. As you can see in the picture here below on the slide, here's a small visualization of what a decision tree could look like for the iris flower dataset. Let's get started with the implementation. To begin, I will import some packages that we will be using throughout the implementation. Those will be pandas, numpy, matplotlib, as well as seaborn for some visualization. First up is pandas, then numpy, and we also have seaborn and matplotlib. Great. Now we can move on to just loading the iris dataset and converting it to a pandas data frame for future analysis. So the iris dataset simply can be imported from sklearn. Now from there we can just create a data variable to store the data. Since it's from sklearn, we can simply just run the load iris function. Now we will convert it to a pandas data frame. Now we have converted our load iris dataset to a pandas data frame, which is going to make it easier in the future to do some more analysis on our data and see what data we're actually working with. Now let's get some information about the data and also separate the labels as well. First up, let's just print the classes that we are working with. As you can see, the classes in this dataset are Setosa, Versicolor, and Virginica. From there, we can also separate the data into X and Y labels. And Y here is going to be the labels. Now from there, we can also simply just print the first 5 data points just to get a simple view of what our data actually looks like. The output here shows the first 5 data points with the futures as well, which are sepal length, sepal width, and petal width. Now we can also check the columns, the number of samples, and also print the first few rows. You can also get the number of samples here. As well as the first few rows. Great, so now we can see some of the actual columns we were working with, which of course are also the futures, and then we also have the total number of samples, which is 150, as well as the first few rows. Next up, we can get some of the correlation values between all of the columns, simply by just doing df.corr. Now this shows some of the correlations between some of the columns. For example, we can see here that petal length and petal width are decently correlated, whereas something like sepal length and sepal width are not nearly as correlated. We can also use Seaborn here to better visualize these correlations with the heat map. And as you can see, the same values here are represented, except using a heat map to make it a little bit more visual and easy to understand. Next up, we can also get a pair plot, which gets some histograms and correlation scatter plots to see some more relationships. Great. As you can see, this delivers a lot more information compared to the previous ones, but nevertheless, this sort of data set is much more simple compared to more complicated ones, so we don't necessarily need these sort of techniques. With that, let's move on to creating the test train split and train the decision tree classifier. So let's do some more imports here to get the test train split. And now we will just perform the split here. Now we'll finally import the decision tree classifier and define our classifier. And now we'll also fit the decision tree. All right, now we can run all of this. Great. Now we have done the test train split and also fit our decision tree classifier. Now let's make some predictions on the test set and get a final accuracy. And we do that by making predictions on the X test set. Now we can output a final accuracy to see how our model did. Looks like here we have to first actually import the classification report, of course, before we can actually use it. So all we have to do, as we've done previously, is just do from sklearn.metrics, import classification report. And we'll also do this for the accuracy score as well. There we go. Now we have some critical metric points that we can refer to actually measure the performance of our model. So we can also use the accuracy score as well for the train and test sets. And now we can also get the accuracy on the train set, or the test set rather. And we can make this a little bit quicker by just copying this here. Looks like we forgot one thing here. Which is just going to be one more parentheses there for the print statement. As you can see here, the accuracy on the train set was 100%, and the accuracy on the test set was 97%. So as you can see, there might be a little bit of overfitting there, but overall, the model was able to do very well, considering that the data set was generally pretty simple. And of course, we also have some other metrics here like F1 score, precision, and recall. Now we can move on to defining, training, and testing the random forest classifier. So we can also import the random forest classifier just like we did for the decision tree. And also note there that we are using sklearn.ensemble because the random forest classifier is an ensemble of decision trees. Now we are also fitting the random forest classifier just like we did for the decision tree. And we're also defining how many decision trees we're actually going to be using with the n estimators. And now from here, we can use the same process as we did for the decision tree to get some metrics here on how the model did. Except this time we'll be using ypred2, and then this will stay the same. And we have to use clf2 here to change that, and then ypred2. Great, so as we can see here, we still have some more metrics here like the F1 score, recall, and precision, and we also do have the accuracy on the train set and the accuracy on the test set. As you can see, the accuracy on the test set is actually a little bit lower at 95% rounded up. Now, as we can see, there's not that big of a difference here. That's largely because this data set is not super complicated where multiple decision trees in a random forest could benefit the model a lot. However, if the data set was much more complicated and the correlations were not as clear, a random forest is obviously going to have a much bigger benefit, as testing random subsets with random features will have a much more significant. Lastly, we are also going to be visualizing the decision tree. For this, we have to import tree from sklearn. Then we just define the figure to be plt.figure, defining the fig size as well. Alright, now if we run this, we get a simple visualization of the decision tree that we created earlier. Notice that many of the features here are labeled, such as petal length, petal width, and more such as sepal length as well. Now we can also see that some values such as entropy are also listed as well. Those are some of the values that we discussed earlier that are used in splitting methods such as information gain. With that, that concludes our implementation and the section on decision trees and random forests. Thank you so much for listening, and I hope you learned a lot about both decision trees and random forests.